Kia ora koutou, Reese from QuickSense here, and today we're looking at lines or planes of symmetry. Now this question is asking us which of the following letters, A, B, C, and D, has at least one line of symmetry. So I imagine some of these are going to have no lines of symmetry, and what we're going to do is begin with A, and we're asking the question, can I draw a line through the center such that the image on each side is the same? And at least with this one here, you can see that the left-hand side is not the same as the right-hand side. We can do it horizontally, and again, not the same. Top is not the same as the bottom. And what about diagonally? Nope. So for A, there are 0 lines of symmetry. Now for B, again, going down the middle, there's going to be no lines of symmetry there. Nothing through the middle, and nothing diagonally. So once more, B has 0 lines of symmetry. C has nothing vertically, but we can see through there, right? If I were to examine the top of that and the bottom of that, they are like mirror images. Because of this, we say that there is, right? So there is one line of symmetry. And last but not least, D. Well, D is like B, but flipped over, right? So it's got the same lines of symmetry, it's just flipped over. So because B has 0 lines, D also has 0 lines of symmetry. So which of the following letters? C. This question here is giving us a diagram, and once more, it's asking us for how many planes of symmetry. So in the last question, it was lines of symmetry. In this one, it's planes. And the difference between a plane and a line is the line is done in 2 dimensions. Whereas a plane is 3 dimensions. So because what we're looking at is a 3-dimensional object, it's a rolling pin, we're going to be having planes of symmetry, where we can cut through that object. So what we're going to need to figure out is some more information about this object. This has a radius, so I'm going to write that down immediately. R is equal to 4.5. 2 identical cylindrical handles, that's going to be important for symmetry. When the rolling pin is rolled 360 degrees, it picks up identical black spots that are 1.5 pi centimeters apart. Okay, so immediately, if I'm looking directly at this, I can see that there's going to be, excuse my drawing, right? We're going to have the rolling pin is going to look like this. We're going to have some number of dots here. We don't know what that is yet. But down the middle, the left-hand side is going to look exactly the same as the right-hand side. So I can already see one plane of symmetry. To figure out how many other planes of symmetry we have, I need to look at cutting sort of diagonally through it, right? If we rotate, so here's the, so this part is here, right? And then this part here is going to be behind it. Ooh. How many different ways can I go through that? Well, if there's no dots, I can go through it infinitely many times. But because we've got dots on there, it could be the case that they're not going to be, so for example, I could have a dot here and a dot over here. This means that cutting through this way, the two dots aren't mirror images of each other. So I need to know how many dots there are and if there's some symmetry there. Okay, so how many dots are there? Well, I know that the diameter of a cylinder, of a circle, the circumference, that's the distance around the circle. The circumference is equal to 2 pi r. And in this instance, the circumference, well, we know what pi is, 3.1415, and r is 4.5. So the circumference is 9 pi. Now you can simplify that, but because pi is an irrational number, it's often better to leave it as it is. The second part is to ask how many or how far apart, how many dots are there, and that's determined by how far apart they are. So they are 1.5 pi apart, right? So how many are we going to have? Well, we're going to have 9 pi, my circumference, over the spacing between the dots, which is 1.5 pi. 9 divided by, well, these pi's cancel out. 9 divided by 1.5 is equal to 6. So I have 6 black dots. So what does that look like? Well, on my diagram on the right, I've got a dot here, a dot here. Let's go one at the top, one at the bottom, one over here, one over here. And these are evenly spaced. So what does that mean for my symmetries? Well, I've got 1, 2, 3. So I've got 1 plane of symmetry plus 3 more planes equaling 4 planes of symmetry.